Hello, this is Mr. Collier, and today we're doing some exponential models. Let's do a couple of exponents first to remind ourselves about some exponent laws. 10 cubed is 1,000. You're going to see that a lot today. 10 squared is 100. Any number to the power 1 is itself, and any number to the power 0 is 1. 10 to the power negative 1 is actually 0.1 or 1/10, and any number to the power 0 is 1. Okay, let's take a look at an exponential function here. Okay, we're going to look at a few exponential functions, and in the form k times a to the power of x plus c. Okay, so in the first example, it's done for you. We have k value is 1, since you don't see anything there, and a 3 and 0, because there's no plus c, so it's like a plus 0. Let's take a look at what that graph looks like. So this is what the graph looks like. As you can see, it's got a y-intercept of 0, 1, and it's got a horizontal asymptote at y equals 0 because it approaches 0 down here on the x-axis, but it never actually reaches 0. And then we have that information listed in here. Let's look at 2 to the power of x plus 3. So I'm going to change my a value to 2 and plus 3. So c, now you see when we change the c value, it goes up. So it's vertically translated 3 up. Okay, that means the asymptote is up 3 as well. So before the asymptote was 0, now it is 3. Actually, this is part C we're doing right now. So that's 1 again. That's 2, and this is 3. The asymptote is y equals 3. It is still increasing. The y-intercept now is 4 because it went up 3. Okay, now let's look at this one here, 0.5x. So this is going to go down to 0.5. You can see once you hit 1, it's a straight line, and then below 1, it's a decreasing function. Okay, so let's pop c down to 0. So it's a decreasing function. The y-intercept is still 0, 1, but it's a decreasing function. So this one's decreasing. The asymptote is y equals 0 again. And these values are 1, 0.5, and the c value is 0. The y-intercept is 0, 1 again. Okay, let's look at number D, 0.4x minus 2. Now this a value is less than 1, so it's still going to be a decreasing function. And we got a minus 2 for the c value. Okay, so it's a decreasing function. We got a minus 2 for the c value, so the horizontal asymptote, let's actually draw it in, y equals 2, or negative 2. Let's change the color. So that green line approaches. If you zoom in, it doesn't actually touch it. The green line approaches the red line, but never touches it. It's a horizontal asymptote. So the asymptote, because the c value is negative 2, that's now y equals negative 2. It's a decreasing function because the a value is less than 1. The y-intercept is 0, negative 1. 0, negative 1, because it went down 2. And these values are 1, 0.4, negative 2. Okay, in E now we have a k value of 2. So it's stretched it a bit. 3 for the a value. C is 1, positive 1. Okay, so we can see the graph here now. The asymptote is actually at 1, the horizontal asymptote, because the c value is 1. That horizontal asymptote is also going to be 1. So we're going to have y equals 1. It's an increasing function because the a value is 3. It's bigger than 1. And the y-intercept is 0, 3. The y-intercept is 0, 3. Okay, and last one, G, we have 3 for the k value. That's going to stretch it more. It's going to be steeper. we've got A is 0.5 less than 1, so it's going to be a decreasing function. Okay, and -2 here. So the C value is -2. That means the horizontal asymptote should also be -2, which it is, right? So y equals -2 is that? It's a decreasing function. And the y-intercept is 0, 1. Okay, so what is the connection between the value of c and the equation of the horizontal asymptote is always y equals c? What's the connection between the values of k and c and the coordinates of the y-intercept? Well, if you look at the y-intercept, it's always k plus c is the y-intercept, see? K plus c is the y-intercept. Always. What is the connection between the value of a and whether the function is increasing or decreasing? For increasing, a is greater than 1. For decreasing, a is less than 1. Okay, now let's move on to an actual application here now. Let's do this one here with the temperature of a teacup. This is how it works. Temperature of tea or any hot liquid starts off high, maybe close to 100, and then it goes down towards room temperature. Okay, so let's call this x and t for temperature. Graph the function. What was the initial temperature of the t? So let's take a look at it on a graph here. So we've got 21 plus 55. All right, let's just type it in. And let's go to shift plot and pick our values. So x is time. I don't know, maybe we need 20 minutes or something. And temperature definitely goes up to no more than 100. Let's see if we can see a nice graph. We can see a graph there. Maybe I didn't need to go so far on the x values. Maybe I can just do 10. And it might look a bit better, something like that. Okay, so it's a decreasing function, obviously, because the temperature is decreasing. It starts off really hot. Actually, let's look at what the actual starting value is. We can go to function and 0. So it starts off, the y-intercept is 76. It's actually the sum of 21 and 55, right? So that's 76, and this is coming down. It's not going down towards 0. Remember that 21 is the horizontal asymptote. Maybe I'll do that in there. So it's approaching 21 degrees Celsius, right? Okay. What's the initial temperature of the tea? Well, that's 76 degrees Celsius, as we saw from the y-intercept. Write that the temperature after 5 minutes. Well, we can look at it on our table, 23.2. So T of 5 equals 23.2 degrees Celsius. 60 degrees is considered safe. How long will it take? Well, we got to graph 60 and find the point of intersection. So let's do that on our app. 60, and we can see the red line there. Let's go to function intersection 0.536, 0.536, comma 60, of course. So that means after only 0.536 minutes, so just about half a minute. It cools down pretty quickly at first, and then it slows down. The cooling slows down. Okay, if you forgot about the T and left it standing for a long time, what temperature will it approach? That's the horizontal asymptote. So it approaches 21 degrees Celsius.